All right. So good evening, everyone. So first of all, welcome to our monthly APOD session. This is the first APOD session for the year 2022, and yeah, we are here today from Astronomical Society of Penang to present you the APOD on January 2022. So before we start, once again, Happy New Year to all of our dear audience, and also a quick introduction. Actually, for this month APOD, we have all old faces which have been present APOD for the past session in last year. But today I would like to a quick introduction. So together with us tonight, we have Dr. Chong, the president of Astronomical Society of Penang, a retired physics professor from University Science Malaysia School of Physics, and he was one of our founder of this Astronomical Society of Penang, and he actively promote astronomy to all our people in Penang. So next we have Miss Chiu Boon Wei, the founder of ASP. She's also our assistant secretary, and she graduated from School of Physics from USM, and she did minor astronomy, so she is expert and also a professional in astronomy. So if you all have any questions, feel free to ask her during this APOD session, and she can answer. She can give a perfect answer to everyone. All right, and of course, it's me also. I'm Lai Hongjun from Astronomical Society of Penang as well, a committee member of Astronomical Society of Penang as well. So before we start, maybe just a quick review on what we have done. Actually, this is the even though this is the first APOD session on January, but for the year 2022, we actually started this APOD online discussion or online presentation session since May 2020, right? When the COVID-19 pandemic start. So this is our number 19, the number 19 presentation. And also, since this is a very first session of the year, maybe I'll pass it to Dr. Chong to give a quick introduction about APOD before we start the APOD today. Dr. Chong?
Okay. Thank you, Lai. So, welcome again to our APOD session. We are now 1.5 years old already. Started, like Lai said, May 2020, right? So, a lot of events have passed under the bridge already. So, I will give you some preview of how APOD started from a personal point of view, my point of view, all right? So, I will share my screen, Lai and Boon Wei. Can you see my PowerPoint, Lai, Boon Wei?
Yes, yes.
Okay, so this is for January 2022 virtual tour of APOD. Because of the pandemic, like I said, we present the universe from our home. All right. So this for January 2022. A bit of history. So I remember it started in 1995, and whoever want to get their picture published in APOD must be good to these two guys. On the left, Robert Nemuro, professor in physics in Michigan Technological University in the USA. And on the right is a NASA scientist, Dr. Jerry Bonnell, work in the Goddard Space Flight Center. So they are the one who look at the submission of the photo. But when they started in 1995, they were not known. Now they are famous. So anyone want to put their pictures in APOD, these are the people in the make the final decision. So they are dealing with APOD, right? So I remember you trace back, APOD first one was 16 June 1990, a simple article on the neutron star, the size of the Earth. Right? I remember internet came to USM, University Science Malaysia, was still a lecturer in 1995. But I was not aware of APOD. I was aware of APOD 1 year later in 1996. So I was following APOD since 1996. And until today, I find that the best source of astronomy information and pictures is APOD, as one picture of the day by NASA. All right. So now this is for January 2022. Now let's go and look at the website. Right, you can see, right?
Yes, yes.
Okay, so now it's as well picture of the bed by NASA. So this is for the today's one is 2022 January 29, the Forest cluster of galaxy. And you go down the list, you more. The whole list you can go down until 1995. So many years have passed by, so a lot of pictures. So what's great about APOD is this: is that from this APOD, you can get like information we cannot get from one source of information except from APOD. So basically, a lot of pictures. So if your aim to look at APOD is just to look at the beautiful pictures, APOD is the place. But if the place to learn more something about astrophotography, APOD is the place. They'll show you how they can take notes of those nice pictures. You want to learn about science, APOD is the thing, because underlying the science, sometimes there's a link to every picture. You find that you learn a lot of science in physics, in mechanics, all right, gravity, biology, chemistry, even history. So some of those pictures taken in APOD are related to history. So basically, it's I would say it's something like a all-in-one astronomy supermarket. It's a supermarket where you have everything is there. So this is so previously I was looking at the Hubble picture website, but later on I migrated to APOD. So this is the one. So let us look at the first picture for today. All right. 29 January 2022, the Forest cluster of galaxies. Right. There's the one. So every blob here is a galaxy. And it's taken by I think maybe the person who took it is Marco Lorenzi, amateur astrophotographer for Italy, and it's held by these two amateur astrophotographers from Hong Kong, Angus Lau and Tommy Su, right? So this is him. But the thing is, because now APOD is so very well established, you need not tell what equipment you use, which location. Just put your name is good enough. Previously, when it started, the astrophotographer, they put what telescope, what exposure, what equipment, camera they use. So now no need, right? So remember, Hubble Space Telescope took, I'll make the picture smaller now. All right? That Hubble took a picture called the Hubble Ultra Deep Field. What is that? The most famous picture taken by Hubble Space Telescope. That is from in the Forest constellation in the southern sky. Forest means the furnace, right? So Hubble took pictures of the furthest galaxy seen by man. Galaxies are close to the edge of the limit of observation for Hubble, something like 13.4 billion light years. Hubble. So it's near there that they took this picture. So it's a Forest cluster of galaxy. So here basically you see here are actually all elliptical galaxies. All right, elliptical galaxy. This is a spiral galaxy. This is a dark spiral, and these are the stars in the Milky Way. So most of them are galaxy, but all the points of light are stars. But the thing is, so beautiful. And this is one of the closest star galaxy clusters. So remember, your stars in a group, Pleiades star cluster, Hyades star cluster, a star cluster of stars. But this is a galactic cluster, a cluster of galaxies. And it's very nice, taken by Marco Lorenzi for Italy, and I mean maybe help in processing by the two Hong Kong guys, Angus Lau and Tommy Su. All right, and here you find that there's also, so everyone here is a galaxy, right? So let's go to the next one, and this selection is best selected by Lai. So Lai must have taken some time to scratch his head. This is the best to choose for this month. And I like this one. Thank you, Lai, for giving me this one. Oh, you. I read it out again. Just to speak about this can speak for half an hour. Like. So Saturn, this is the planet here. That is, this is the moon of Saturn. And the shadows, the shadow of the ring. Now, look at this is the main ring. Remember, Saturn has 7 main rings, A, B, C, D, and so on. And Saturn has many ringlets. And this is the shadow of the ringlet. And this is the moon called Thetis. And of course, this is taken by Cassini Imaging Team, meaning many years ago, NASA launched an unmanned spacecraft called Mission Cassini that went into orbit around Saturn and is still orbiting around Saturn, and then took pictures of Saturn and the planets, on the moons and the rings of Saturn. I really like it. And also by SSI, Space Science Institute, all right, and American Research Institute, JPL, be everybody know, ESA, European Space Agency, and NASA, all right. So here you see beautiful. For if you are in a kind of Cassini, you look at the rings of Saturn, it's so nice. But then I'll give you some extra information of Saturn. Yeah, this is the moon Tatis. So Tatis is a strange moon, you know. So it seems it's basically made up of mainly ice, frozen ice, and a bit of rock. Because its average density is less than that of water, less than 1 gram per cc. So imagine you throw the whole of Tatis in a big basin of water. Tatis will float in the water, lighter than water. So it's frozen ice with a bit of rock, all right? Because it's made by Cassini in 2015, all right? That's it. And then the ring you saw just now is this. So you see the what they call here is the main ring, all right? And here you find all the ringlets. So we go back to the presentation. So this is the main ring, and this is the gap between the ring. This could be the Cassini division, the light passing through the Cassini division here. So what's happening here? The sun is on the lower right-hand side. So the light will be blocked by the ring to have a shadow here. But in between here, there's a gap here, Cassini division. So the light will go through and fall onto the upper atmosphere of Saturn. All right. And you see here, the ringlets. And here is Tatis. So this is actually what? This is actually looking at the equatorial region of Saturn. But you see, you look here. So we now know that these are the main ring. And altogether, Saturn has thousands and thousands of ringlets. That's it. Right? So these thousands of ringlets, it's not so, in other words, you cannot say Saturn has 7 rings, the 7 main rings, but there are thousands of ringlets. So actually, this is an old story. This is a bit of old story. So there was this French mathematician and astronomer, Pierre-Simon de Laplace. So at that time, he used, they was in the 18th, 19th century, he used the calculus invented by Newton, Isaac Newton, and also the law of gravity, and he proved that this ring of Saturn, as seen through the telescope, is not a single disk orbiting around Saturn as a single disk, but made up of many millions and millions of tiny particles up to a size of about a few meters. A few meters like the size of your motor car, right? Up to the size of a tiny grain of sand. So they are all individual moons orbiting around Saturn. She proved that, right? So that's it. So that is found by this, proven by the mathematician Pierre-Simon de Laplace, right? So this is the law of gravity, right? So basically, how did all this thing come? You can prove it by the law of gravity, which we know that one mass and another mass, attractive force, directly proportional to the mass of the two masses, and inversely proportional to the radius, distance between them. The law of gravity, right? Okay. And then this energy, now you look again at this thing, that is, luckily it says here that is now is about very far away. How far away? 300,000 kilometers. So Tatis is 300,000 kilometers from the center of Saturn, because it's 300,000 kilometers. So Tatis, fortunately, outside the so-called Roche limit. Now, this Roche limit is actually discovered by a French mathematician, Edward Roche, many years ago. So what did he do? He said that if you have an object, the orbit around a planet, all right, and that object is within the Roche limit, then the tidal forces of the planet can break up the moon, and it may form a ring around that. That's how the rings of Saturn came about. But luckily, Tatis is outside the Roche limit. So the gravity of the Saturn not strong enough to break up the moon. So in a sense, they all now know that, so in other words, the rings here are much closer to the Saturn. In other words, the rings here are within the Roche limit of Saturn. But Tatis here is outside the Roche limit. Luckily, our own moon is away from the Roche limit of the Earth. If within the Roche limit of the Earth's tidal forces will break up the moon, and then the Earth will have a ring. But this is not the case, because our moon is far away from the Roche limit, all right? So because of the Roche limit, so everything can be explained, all right? We go to the next picture. 21st of January. This is interesting. Okay, so 20th of January, and the title says, I'll go up later. Young Star Jet MHO 2147. All right, taken by the International Gemini Observatory, NORAD, National Science Foundation, AURA. AURA is something like Association of Universities for Research in Astronomy, a group of American universities. They come up as a consortium. So these are all American universities, and in the famous Gemini Observatory. Remember, in two places in the world, one is in Hawaii, Mauna Kea. That's the Gemini North. Inside there, you have a reflecting telescope or single mirror, not segmented mirrors, single mirror, 8.1 meter, and that's in Hawaii. And there's an identical twin of this Gemini telescope called Gemini South in Chile, all right, and also 8.1 meters. So basically, this picture was taken from Gemini South, all right, and it's a picture of, I say here is from it's at the boundary of the constellation of Sagittarius and Ophiuchus, all right. So here, boundary of Sagittarius and Ophiuchus. Sometimes they say that Ophiuchus is the 13th constellation because the plane, the plane of the ecliptic passes through the Ophiuchus, you know. But somehow or other they left out Ophiuchus. So some people by right, their date of birth is when the sun is in Ophiuchus, but they are not called Ophiuchus. They're called either Sagittarius or the other one, Capricornus. All right. So that's not. So basically, in Ophiuchus constellation, you see a dark lane. Right. They see some of the stars here, and you see they from the way you look at it, there are a few stars blocked by this cloud behind, and one of the stars that give off the light emission is spinning like a clock, and as it spin, the star is precessed. What do you mean by precession? That means you have one star in the center of the star cluster, and the other stars near it are pulling on the center, the star in the center. So as the star in the center will spin, it will precess. So it precess, it will like throw out this spinning thing. Like in Malaysia, it's called gila. That's throwing out all the gas come out. So you can see it. It's so beautiful. All right. So that's it. So what they're saying here is partly they're MHO 2147. Right? We go to the next one. Very nice one. I really like this one. January 18. Wow. Okay. From Orion to the Southern Cross. Okay. By Miss Lucy Hu. Okay. So actually, Lucy Yunzi Hu is a actual researcher in Australian National University. So she got the actual, she's doing an actual studies in PhD, and also she's lectures in statistics. So you find that it doesn't mean that all the astrophoto must be taken from very well-trained amateur astrophotographers. No, she's actually working in, what is the actual study? Actual studies means that you are studying all the statistics, so how you can set the insurance premium. So this is a very good job, you know, very high pay, you know, right? So you study all the statistics, so you set the insurance premium for whatever type of policy you want to buy. So actual studies, and she's also a statistician. But her pastime is what? Astrophotography, right? She's still very young, you know, right? So here you look at here.
So young. I can also do.
You go into her website. So she's actually an actual research fellow in Australian National University, Canberra, Australia. Right? So basically here, I really like it. So basically, he's taken here from a place called Bombo Geological Quarry. Somewhere you can remember the geography of this Australia. On the bottom right-hand corner of Australia, you have New South Wales. All right. Somewhere a bit north in the New South Wales, you have the city of Sydney, biggest city in Australia. But below Sydney, on the east coast, is this place, Bombo Geological Quarry, right? And there you are, the Southern Pacific Ocean. Beautiful. And then he took it, basically he took many shots. He took about 18 pictures, and then he teach them to get this. The scenery below here is taken in one shot, but the sky is taken in 18 shots. And then you see Orion, beautiful, right? And then the belt of Orion, you can see the Barnard's Loop. You have, hey, how can terbalik, upside down, Betelgeuse, Bellatrix, Rigel Sahib, and here's Anita, Anila Mintaka, and 42. Because this is Australia, far south of the equator, closer to the South Pole. That's why even Orion looks upside down. Right? And so you have here Sirius in Canis Major, Lepus, Canis Minor, and this star is, of course, Procyon. Some religions say Procyon. I call it Procyon. All right? And here you have large and small Magellanic Cloud and the Gum Nebula, Eta Carina Nebula. And here you have the Southern Crossroad. But what I like is, you see, I don't know whether she took it early morning or in the evening. You see the weather is getting cold, and you see the mist is forming. A bit of mystery there. So nice, all right? So this is our Miss Lucy Hu from Canberra, Australia. All right, very nice. The next one, 17th of January. This is interesting. I read out Chameleon Dark Nebulas. All right. Of course,
this one is the Pokemon.
Yeah. The other day I was talking to our member Muhammad Daim. So I used the word nebulas. He said last time I don't like the word nebulas because the older people in Australia like nebulae, Nebula. In Latin, nebula is a cloud in Latin. So in Latin, the plural is nebulae, right? But then what to do? Many of us now will follow the new way. Nebula, nebulas. So the Chameleon Dark Nebula. So it's interesting. Why the name Chameleon? You look here at the picture. Now, a chameleon is a kind of a lizard. This is a chameleon from Madagascar, a big island in the Indian Ocean to the east of Africa. So this is a chameleon, same chameleon, not four, that can change into seven colors in 3 minutes. In 3 minutes, it can change its color, but here they take four colors. So a chameleon is a type of lizard that can change color. So that's why they named this one all right, they call this Chameleon Dark Nebula because you see here, it looks like there's something changing here. Okay, so I will just scroll there. I'll read out the name. Later on, I'll explain what's happening here. The interesting one is Beta Chameleon, the second brightest star in this place. Remember, we follow the Bayer classification. The brightest star is Alpha. The second brightest is Beta. The third brightest is Gamma, Delta, and so on. All right, and this is Epsilon Chameleon, right? And then this is Moa Nebula, and this is IC Index Calculus 304. They call it Mars 8, and it's actually a galaxy. So this galaxy here is far away from our Milky Way, very far. But all these dust cloud, all these reflection nebula are much closer. And this is the Tampri Nebula, and this is a Tello Nebula, Rippling Flames Nebula, right? So the interesting thing is actually all the dust cloud. All right. So this is in the constellation of Chameleon. The constellation of Chameleon is just above what we call Octantis. Remember, Octantis is the constellation where you have the South Pole. So this is a constellation just above the South Pole. All right. Now remember, for us in the north, we say that northern star is Polaris. All right. Alpha Draco. All right, Alpha Draconis. But for the people in the southern hemisphere, their South Pole star is Sigma Octantis. It's not very bright compared to Polaris, but with a telescope you can see. For example, you look at the Brazilian plaque. The Brazilian plaque is actually an astronomy plaque. There are many star constellations there. So Sigma Octantis, the South Pole star, is there. All right. So now you look at it. So this is there's a lot of dust cloud. All right, and it looks so nice. So basically, the explanation here is that it's a lot of dust cloud. So what do you mean by dust cloud? And it is like this. You may say, I think they must have touched up the color of the dust cloud. They put it chocolate color, brown color. No, it's explained that because the dust cloud will receive the light from this bright star, which is in ultraviolet. The particles of dust in the dust cloud will absorb it and re-emitted it in longer wavelength. So received in UV light, visible light, but scattered off in infrared and red light. And you look at the color, looks like chocolate lah, because infrared, red light, like this. So basically, this is the natural color of the dust cloud. So this is, and remember, this is the House Eagle and Possum Nebula. So what do you mean by this? So I will say again, welcome to the Astronomical Zoo. Remember, in astronomy, we learn of all kinds of interesting objects, named after animals, even the names of people, fishes, right? And then the birds, all right, all kinds. So welcome to the Zooniverse. So basically, in this place, it's like a zoo. Chameleon, mouse egg, talon, all right, thumbprint, human beings thumbprint. So very nice. And if we wait long enough, that means people who study exoplanet. Remember, there are scientists around the world have already discovered close to, until today, 5,000 exoplanets. So some of them are actually doing the theoretical simulation of how this dust cloud will collapse due to gravity, and you wait long enough, a star will be born, or star cluster will be born, and aliens will be born, right? And it will take a lot of many years for this to happen. And you'll be surprised, our whole solar system, the planets, the atoms in the body, once also came from this type of clouds that collapsed, and the solar system was born. And then the important question is, imagine I have here a big star cloud, or say one cubic light year. 1 light year times 1 light year times 1 light year. So many trillions and trillions of tons of dust. You collapse to form a new star. Question, how long will and how much of this dust will collapse to form the star? You'll be surprised, no? The people have worked on the simulation using, again, law of gravity, and then this calculus, and of course computer simulation. Only 1% of the dust cloud will form the star. In other words, the atoms in the body, the atoms that make up the Earth and the planets, the solar system, and the sun, is only 1% of the protosolar nebula that collapse to form the solar system. The rest of it is evaporated away. So we have the 1% left from the protosolar nebula, right? Like this. So, and then this, I forgot to give the name. So I give a name. This is our, because he's from Finland, we pronounce his name as Jarmo Ruth, well known as amateur astronomers from Finland. And he actually, with a group of amateur astronomers, they run the telescope live observatory. Right? There are now many of the online robotic observatory. He runs it, and also another Heavens Mirror observatory in New South Wales in Australia. So there are many of these online amateur astrophotography observatory. Okay, so I stop here. I pass over to Mr. Lai.
All right, so let me share my screen for a short while. So can see my screen,
Yes, Lai.
Okay, so good evening again, everyone. So let's proceed to the next APOD on 16 January 2022. So just a simple soft reminder to all of our audience, if you all have any questions, feel free to communicate with us through the comment section in the Facebook our Facebook page, the live session, and also the chat box on the YouTube channel. So let's start with 16th of January 2022. So the title is A Retreating Thunderstorm at Sunset. So this is a thundercloud. It's actually called cumulonimbus cloud. And clouds to astronomers actually is something that we don't like, especially when we're having stargazing. Especially in Penang also, we experience a lot of such situation where we have informed our members that we are going to conduct a stargazing before the pandemic start. We inform all our members that we are going to have stargazing in Kapasing Drive, but at the night when we start, it's cloudy. All right, so clouds is something that we professional or amateur astronomers that we don't really like. But clouds is actually important, and clouds can tell us a lot of information. So this kind of clouds, all right, this type of clouds, this type of clouds is known as cumulonimbus clouds. Okay, and we have a lot of different types of clouds. Okay, learning about clouds or recognizing clouds is important. All right. So before we proceed further about clouds, I'd like to mention that this image is taken by Alan Dyer. Alan Dyer is a Canadian professional astrophotographer, and also he's a professional writer for planetarium show across Canada and America. And he's also a well-known Canadian astronomy writer. That means he writes a lot on astronomy. So these clouds, all right, back to the clouds. All right, so these are clouds. So clouds are important, all right. So understanding clouds can actually tell us about the climates of a planet. All right, on Earth, studying clouds, through clouds we can predict the weather. Right, we do a little bit of weather forecasts from the clouds as well. And if we are studying other planets, for example, if we are exploring Mars, all right, if there are clouds on Mars, all right, it can tell us about the weather on Mars as well. So clouds can provide a lot of information. And not only in astronomy, understanding other planets, we learn about clouds. All right, as aerospace engineering students, all right, in aerospace, there's a subject. Of course, in USM, when we study aerospace engineering, we don't study about clouds, but there's a subject a course offered in this under aerospace engineering or aeronautics engineering on anti-icing. We call it the anti-icing system design. The first lecture we start is recognizing clouds, all right, because different types of clouds, all right, when your aircraft fly through, you experience, because different types of clouds, the humidity or the water content, the liquid water content, the temperature, the density is different. So when your aircraft fly through, all right, the different temperature, different type of ice will form. So some ice, the adhesive is very strong, will stick on the on the aircraft wing or aircraft surface, and that one is very dangerous. And some ice, the adhesive force is not that strong, it can peel off easily. So understanding different types of clouds is important in engineering studies as well. And just a little bit more information, like this type of clouds, such like cumulonimbus clouds, this type of clouds is known as the OH mentioned thunder clouds. That means this type of clouds is very dense, so it have a lot of water vapor inside, so it have a high tendency to form, or very high potential to produce lightning and dangerous weather. So for this kind of clouds, when we are flying an aircraft, we will try to avoid. If our radar it shows this type of clouds, we will try to avoid this type of clouds because it's very dangerous. We will not fly through this. All right, we will try to avoid this. All right, next, let's proceed to the APOD on 15 January. So 15 January is Europa. All right, Europa, Galileo's Europa. So this image credit is from NASA, Caltech, SETI Institute, and of course it's processed by Marty Valenti and Cynthia Phillips. So when we see about SETI, then we know about this is the mission to study about, in layman terms, we call it to study about aliens. All right, but SETI actually stands for Search for Extraterrestrial Intelligence. All right, this is the full name for SETI. All right, but you can just remember in such way that searching for aliens. All right, that means it's actually searching for life outside Earth. So Europa is one of the target. All right, why? Because study shows that. Not study shows that, actually it's also proven. We can, from this image, we can actually see the evidence of under the surface of Europa. All right, it's actually liquid ocean. All right, so Europa is one of the moon of Jupiter. All right, if we look through telescope, we will see Europa, but then we will not see Europa in such way. All right. So if you see through telescope, right, in a Jupiter, you will see Jupiter, the main star, and the 4 satellite. All right, Io, Europa, Ganymede, and
Callisto.
oh, yeah, and Callisto. So you will see through a telescope, you will see Jupiter this way. All right, but you will not see Europa this way unless you have a very, very powerful telescope, or you need a space telescope. Usually, you need a space telescope or a radio telescope for that. So why scientists says that the bottom or below the surface of this Europa is liquid ice is actually proven or hint by this dark curve, this curve, all right, this curve, the surface curve over here. So it's actually mentioned in the caption down here. So it's not mentioned here. Never mind. But then this dark line, actually, this dark curved line, okay, actually is evidence that the bottom of the Europa might be liquid water. And why? Sorry, and because of the sub layer of Europa is liquid water, that's why it attracts the interest of scientists from Earth that this liquid water might support life in Europa. All right, and also and also a little bit more information about this. Sometimes people might ask, Europa is so far away. So Europa is so far away. So it will have a very little sunlight. All right, no sunlight. So one of the important element on Earth, the main the main source of energy from Earth is our sun. But Europa is so far away. All right, about a few times the distance from the sun to the Earth. So since it's so far away, how can it have Earth? So the energy of this moon or this satellite for Jupiter, it might come from this tidal flexing. Right? Tidal flexing is a case like it's something like this. So it's actually the effect of the gravity and the gravity of the moon itself and the gravity of Jupiter. So imagine that you have a planet, or you have a planet, all right, or you have this is Europa, all right. So when it's near to the Jupiter, when it's on the periapsis, because it have an elliptical orbit, right, the orbit is elliptic. So when it's near to Jupiter, on the periapsis, right, the effect of gravity, because Jupiter is huge, the gravity is strong, so the effect of the Jupiter's gravity will affect the surface. So it will try to pull the liquid water on the sub layer towards the one side of Europa. Okay, when it continue to travel and when it reach the further distance, I mean it is further from this Jupiter, then the sorry, initially the water which is pulled by the Jupiter's gravity will return to its original initial position. That means it will go back. All right. Okay. Initially, it's a sphere like this. So when it's near Jupiter, all right, it will elongate a bit. All right. But after that, when it's far away from Jupiter, and it will go back. So the frictional force, all right, will generate enough energy, will generate the heat to support life. So this is the explanation on scientists where this tidal flexing might be the important source of energy to support life in Europa. All right, so next let's move on to the next APOD on 14 January. Oops. January is NGC 1566, the Spanish Dancer Spiral Galaxy. So this is a spiral galaxy known as the Spanish Dancer. So Spanish Dancer is nothing to do with Spain or nothing to do with the dancer from Spain. All right, it's not a human. All right, but it's actually an animal. All right, it's known as a sea slug. All right, so this is a Spanish dancer. All right, not the dancer. All right, so yeah, this galaxy actually looks a bit quite similar to the Spanish dancer. All right, if you slightly rotate the orientation, so it's something like this over here, which is something, yeah. Sorry. So this image credit is from Mark Hansen and Mike Selby. So Mark Hansen is actually a professional astrophotographer from America, and currently he's in Chile. All right, he's expert in doing this remote astro imaging. That means he do not need to be present in the observatory to do the astro imaging, but he can remotely control the telescope in the observatory. And also Mike Selby. Mike Selby is currently in this central of Thailand, in the observatory, the SC observatory in central of Thailand. So this Spanish dancer, or NGC 1566, is a weak bar spiral. That means at the center, all right, the scientists propose, or astronomers propose, that there is a weak bar. So it's a weak bar spiral. It's a spiral galaxy. All right. Our Milky Way is known as the bar spiral galaxy. You can see a very obvious bar on the center of Milky Way. But for Spanish dancer spiral galaxy is more towards a spiral, a weak bar in the center. All right. So yeah, the size of this Spanish dancer is more or less about the size of Milky Way, slightly smaller in the span. All right, the span of Milky Way from the leftmost arm to the rightmost arm is about 105,000 light years. All right, but for this is about from here to here is about 100 light years. Okay, from here to here is 100 light years. And it's a to find this Spanish dancer spiral galaxy. All right, it's a southern hemisphere sky object, so you need to search for the constellation known as Dorado. Right, Dorado. Okay, Dorado. Dorado represents. It's actually a Dorado is a Spanish word, is it?
Mhm.
Yeah, in the Latin word it means dolphin. All right, but then now the translation is swordfish, the swordfish. So it actually looks really like a short swordfish, right? This is the body, this is the mouth, and this is the tail. So this is the Dorado constellation, and the Spanish dancer is somewhere here, all right, on the southern part of this Dorado. Okay, let's proceed to the next APOD, which is on 8th of January, 2022. So this is on quadratids on the north. So quadratids meteor shower is the first meteor shower of the year. All right, every year is on. For this year, the peak is on 4th of January. All right, and it can be observed, and it come out from the constellation of quadratids. And the source of this meteor is actually the dust lane of an asteroid. All right. For example, the previous Gemini, the Gemini meteor shower, I think it's also from asteroid, right? Yeah, if I'm not mistaken, it should be from asteroid. And then the Perseid meteor shower is from comet, if not mistaken. All right, and this quadratids is from asteroid as well. So this image is taken from this Mingan-Hu observation base, or astronomy observation station from Mingan-Hu in Inner Mongolia. And this image is taken by Luo Cheng. So that's about it. All right, for 8th of January. Yeah, so this is for quadratids taken in Mingan-Hu observatory in this Inner Mongolia. Yeah, maybe share a little bit about this Mingan-Hu. So Mingan-Hu is actually a person for our participants in our astronomy quiz for secondary school. All right, maybe this year we'll ask about him. Mingan-Hu is a Chinese astronomer and mathematician in the Qing dynasty. Right, so this is him. Right. Next, let's proceed to the 7th of January, ecstatic solar eclipse. So before we go into the caption, right? Actually, this photo itself already tells a lot of information. So when you see this, right, this is actually the penguin, so that we know that this image confirmed is taken from the Antarctica, right, from the from the South Pole, from Antarctica, because only Antarctica you can find penguin, and of course there are penguin in other places, but then the most of the population of penguin are located in this Antarctica. So yes, on 4th of December last year, there's a total solar eclipse can be observed in the South Pole. All right, so eventually from Malaysia or from Northern Hemisphere, we are not able to observe that. So this is the eclipse map. All right, so this is the eclipse map. So in Australia, you can observe. All right, in Australia, you can observe that, and then in New Zealand, you can observe that as well. But in Malaysia, sorry, we are not able to observe that. Okay, so this is the eclipse maps. All right, so yeah, just to point out something interesting is the eclipse map. All right, you will see two red star. One of the red star is the greatest eclipse. That means this is the point. This is the point of the time that you can see. That means somewhere around 7:30 UTC, you can see. After 7:30 UTC, you can observe the greatest eclipse, the total solar eclipse, which is the greatest over here. But the subsolar point is actually somewhere here. All right, slightly towards the north of the greatest eclipse. That means if the sun shines directly on Earth, all right, if the shadow, if let's say sun have a shadow, it goes directly and it falls on this point of Earth. So this is called the subsolar point. So during an eclipse or in an eclipse map, all right, subsolar point and the greatest eclipse, the position, are not exactly the same. All right, are not coincide. All right, are not coincide. So back to this image. All right, so this is an image on taken by Annie Smith, Dr. Annie Smith. All right, is a researcher. She's actually she has this biology background actually. All right, she's not a professional astronomer, and she has nothing to do with this astronomy, but she is studying about the ecology of penguin, Adelaide penguin. So this penguin is vocalizing. So why penguin are vocalizing is because to claim their territory. All right. So during the eclipse, the penguin claiming its territory on the Antarctica, in Cape Crozier, Antarctica. All right, and from the observation spot taken by Dr. Annie Smith, the moon shadow will cover the moon around 80% of this. Will cover 80% of the sun. All right, so it's a partial solar eclipse observed. All right, so that's all from me. Next, I'll pass to Boonwei to continue with the APOD presentation. Thank you.
Hey, thank you, Lai. So next is me. I will present on the 6th of January APOD. Let me share my screen first. Okay. So is the tape is visible already?
Can see.
See, yeah.
Scroll up a picture. I cannot see the whole picture.
Oh, I need to scroll down.
Yeah.
Yeah,
now better.
this one is the photo on the 6th of January, April. Sorry, 6th of January. And then actually at first I see this photo, I will thought this one is
80%.
This one is the moon. About 80%. But in end, I see on the caption is saying that this one is the Venus. So only I know that the Venus actually we have the face like the moon, and this one is the uh, last day of the Venus to look at the to be visible in the evening time. Yeah, and this oh, I forgot to mention the uh I forgot to mention the photographer of this nice picture is taken by Thomas Ledeny, who is from Hungary, and he is an amateur astronomer and a very professional photographer. And so this photo is actually taken on the January 1st of January, but in the in actually in the 9th of the January, we cannot see the Venus, and until today it the Venus will be rise in morning already. Yeah, so it's actually appearing in the morning, and also is in the February of the 13th, the Venus will be at the greatest of the Berian Sea. We can actually see it. Why is the Venus has so many face is because because of this at the after the 9th of January, the Venus is at location here. We actually cannot see it, and in the from now we are actually can see them as again like a crescent moon. Then this will be appear until the Venus will appear in the morning until the late September in this year, and then it will go behind to the sun as the superior conjunction, and then after this it will go in the evening again. Yeah, so I will go to the next image, which is on 5th of January. So this one is the sunrise in year 2021. We can see that the sunrise has rise in many position, which actually at last time I every time across the bridge I also can see the sun always rise at sometimes it at point here near to the south, and then sometimes it's near to the north at this point. So why is it is because that the sun this is because that our earth is actually rotate the sun in not a circular, and also tilt is about 23 of 5 degrees Celsius. So we can see that at we can see that this is how the earth rotate. And so at the winter solstice, which is here, winter solstice, this one is the December to the June, is from the most south to the most north here, and is go to here and then go back to this. And you can see from this two image is actually at this is when the sun at the equinox, and is exactly at east. So sunrise is not only limited at the east, but it actually moved from south to the north and then go back to the south in whole year. If want to see actually on the when the sun is on the sky, it can actually move it like a H shape, and this is why this is because of the orbiter of the Earth to the sun.
So, but this one is taken at different time depending on the sunrise, right?
Yes, this one is taken. No,
So
this
that
one is
means, for example, the first one will be taken at 7:30, and then the second one maybe 7:28, and then 7:27, something like that, right?
No, I think right is the
no.
moment of the sunrise, he took the picture. No need
Yeah,
to.
I mean in terms of time. So maybe the first image is taken at 7:30, and then the second one maybe 7:28, and then the third one maybe getting earlier and then slowly getting later, right? Depending on the sunrise time of the month. No?
I think
Yeah,
he took it whenever the sun arises above the horizon. That's the time to take. Don't care what the time is arrived. And don't forget, the guy may not be exactly the same time. Maybe he had to dress up or so it'll be plus or minus a few minutes.
yeah. You see the sun also not not so. Some is like already overhead already. Some still rising ma.
So basically, I add on, Boon Wei, so 23.5 degrees times 2 is 47 degrees. That means from the right side, summer solstice, to the left side, winter solstice is 47 degrees. In one whole year, it can change.
So this image is actually taken by the Luca Vancella from the Canada. He's a skyscape photographer and like to focus on the image on moon and sun and the planets as well. Yep. So
very nice idea. Very nice idea.
This is a very nice idea to take the photo with the same. I mean, I think at the same location lah. You can see all the tower is at the left side.
But don't forget, Boon Wei, one whole year, no. Every maybe first day of the month, every year.
One whole year from actually December of 2020 to December of 2021. 13 images. Can be very patient to wake up in the early morning, wait for the sunrise.
But that's one thing I can see. The weather in Edmonton, Canada is very clear. In Malaysia, it's difficult. Always got clouds one.
Sometimes we cannot see
the whole year. You can see it's clear. Yeah.
So that means to do this, he just need to wake up one day in a month to shot this photo.
Yeah.
Because 1 month only one sunrise photo so that means he need to wake up one day lor.
Yeah. If the weather is clear lah. If the weather is not clear, don't wake up.
Oh no.
Very nice idea. This is very nice idea.
Maybe you can find one day, like 1 month, find a day to take this photo.
Yeah.
So next one, I will like to talk about not this one. I'm talking about the comet Leonard. Actually, it's very, very famous in since last year. I was trying to take photo with Chun Kat. I want to join them in one of the after the sunset time. But the day I go to Chun Kat observatory, the sun the sky was not so clear. I cannot see. I have lost the chance to see the comet Leonard already. But this one is a very, very nice photo where we can see the comet Leonard with its tail is actually around 36 degree long. It's very, very long and eventually it's a curve. I mean some tilted tail, and believe it's because of the interaction of the comet gas and the dust with the solar wind when it passes through the sun. Because this is the image taken when the comet Leonard is closest encounter with the sun, which is occur between the orbits of Mercury and Venus. And this image is taken by the Jan Hattenbach. Is a astronomy and science journalist, and he's amateur astronomer from the Spain. This image is actually a mosaic photo, and using the camera with a lens, telezoom lens only. No, just a camera, I think. Yeah, with the 50 mm lens.
Question, Bunmi, allow me. Why is the tail bent? Where it's from the bottom right, it goes up. Then as astronomers, it bent towards the left. Why is it bent?
Actually, I thought it's because it's the solar wind to the magnetic field to extract the molecules and the in the and from the ions, right?
Yeah. So I think you're correct, because we are looking at there are two types of tail: the dust tail and the ion tail. This is the ion tail. Ion tail is caused by the solar wind particle, which are the electrons and protons from the sun, hit the ions in the tail of this comet Leonard, and you kick them into space. And because they interact with the solar magnetic and the solar system magnetic environment due to the sun, so it produce all the king, all the bend.
But I thought the bending is on the coma side instead of after so long the bending only happens.
But because we know that, of course, the solar magnetic field originates from the sun and it goes away from the sun beyond Pluto and beyond. But of course, we don't expect the solar magnetic field to be very strong. But although this big solar magnetic field is big, over a long time, over a long distance, it can deflect the direction of travel of those electrons and protons and ions in the ion tail. So like that. So long distance to do it. So maybe, I don't know, you can make a calculation, you know. Remember when the Halley's Comet came in 1986-87, at that time they said, what is the biggest object in the solar system? Answer, Halley's Comet. Bigger than 150 million kilometers, the distance from the Earth to the Sun. So you can measure, this could be the biggest object in the solar system. Could be many millions of kilometers long. Yeah. Right? Will we continue?
Yeah. Okay. So actually now we cannot see the comet Leonard already. I tried to find the time for this is will be rising in noon time. So if still want to see the comet Leonard, maybe we have to go to the southern sphere already.
You can. Its period is 80,000 years. So if you live another 80,000 years, in future you can see
80,000 years. If I can live so long.
You come back.
Yeah. So the next image is actually very nice image with the quadruped lunar halo over the winter road, taken by the Danny Cassett. But this photo was actually taken in 2012. Like I see them is actually taken in 2012. And how is it is how to say is quadruped lunar halo is because you can see this and four rings from the brightest moon. This image is taken by Danny Cassett. Is also a professional astrophotographer from Spain. This was taken in Madrid, Spain. And why is it there's formation of halo? Let me enlarge the halo photo and explain in better is this. Yeah, you can see quadruple halo is actually saying this the 22-degree halo, and the outside there is a circumscribed halo with with more color like a rainbow, and another wider is 46-degree halo, and outside the rainbow light is the infralateral arc. And how to see this one is the 22-degree halo is like I try to see is like they are trying to stretch the hand to the stretch out the finger at the arm's length, and then the thumb and the little finger will eventually see from moon to the ring is means the 22-degree halo. And this is actually formation because of the reflection of the lights into many tiny hexagonal shaped ice crystal that floating in the upper atmosphere. And during the very very fine day, I think we can also see this halo from the sun.
Just to add on a interesting story. Not story. Actually, it's a interesting incident. All right. Actually, this question, many people actually confused about this rainbow and halo. So in 2020, when we have the first astronomy quiz for secondary schools, the questions of rainbow and halo actually kill a lot of students. They are confused with halo and rainbow. So halo is actually from ice crystals. The main difference is halo is from ice crystals, and rainbow is from the reflection of water vapor in the air. Right. So this is the main difference. So rainbow always appears on the opposite side of the sun. So you will not able to see rainbow during noon time. All right. You only see rainbow either in early morning or in late evening before sunset. All right. Yeah, but halo you can see during noon time.
Yes.
So this is the difference.
Very nice picture, no? Bunbi, I like this.
Yes, I like this is also because it's actually taken in the winter time, and I can recognize the Orion here.
Yeah, and then the photographer purposely did a trick. You know what's the trick? Look at the road, Why on the left side of the road? Why the road curve up, and in the center it comes straight, and then on the right side it curve up. Simple.
Is it because of the wide angle?
Fish eye lens. So the fish eye lens will make the lens closer to the photographer, curve away, so that he can see the more parts of the road lah. And so look our very special effect lah. Looks like very special effect. Normally you don't see lah. Very nice.
So I will go to my last image, which is the moon, the full moon photo in year 2021. Yes, this one is actually composite of 12 months of the full moon into one picture, and the original should be looks like this one. This one is all the 12 full moon that taken by photographer. The name is a little bit hard to get. Yep. So this is his Instagram, and this is taken using the same camera, which is the Nikon D5600, and at the same focal length. It's take all the photos in 300 image each, and you can see from this image, you can see some misaligned. This is because when the moon orbit around the Earth, it is also orbit not in a very circular, and it has the longer perigee and the apogee. So it has a different angular size changes, and also different kilometer when it is the nearest and when it is the furthest. So from this image, this the nearest is the in the May, and the furthest is in December. So in May one, you can see is actually, I think it's the quite big one, and the December is the smallest moon. And these names are actually from the Native American, which actually describe month, their month of the moon. Like the January is the wolf moon, means I think the wolf will be changing at this month because the wolf moon means the wolf will be start to prowl hungrily around the village. I can imagine that the wolf standing at the, how to say, the cliff there, and then ooh, on the moon. And so the February is the snow moon. In Chinese, I always think February is a CNY, Chinese New Year, the Lunar New Year. So means it's near to the spring already. But in February is actually a coldest month in America. So sometimes it will snow. So they will call it the February moon is a snow moon, and the March is the earthworm will start to emerge, and April is named by a pink moon, but the moon is not really looks pink. Is because it's actually saying the pink flower will start to bloom in the spring. Then in May, of course, it's a spring already, so it has many flower blooming already. And June is the strawberry moon, means we can start to have many strawberries. But yeah, so every moon got their different meaning. So like July in Chinese actually is the hungry ghost moon, but they are actually they are not so scary. They are actually very romantic. Is the bug moon. Yep. So I think the October moon is very nice moon, is because they will start to do the hunting games already. Not sure the Hunger Games in the movie, is it start on Hunter Moon also, October? Yeah. So December, of course, is a cold moon. We can know, yeah, December is very cold. So this
One comment. This one, a guy who from Australia and Chile cannot appreciate.
Why?
The name, the date of season all to Bali. Cold moon for northern hemisphere, but in December it's very hot in summer in Australia, in Chile, in Argentina. So those people cannot appreciate. So this is for the people of the northern hemisphere. Equatorial region can use also.
Yeah. So here ends my APOD sharing. I'm so sorry. not saying so nice.
Very good. Very good, right?
Okay.
And a good way.
Yeah, so we have Q&A session. From the Facebook site, William made a comment where he said, Malaysia morning sky is always clear actually, but the clouds like the horizon.
Yeah, that's it.
Yeah. And then from our YouTube channel, there is no comment in the chat session, no questions. All right, but yeah, again to all our audience, so if you all have any questions, maybe you all can just type it in the comment section in the Facebook live session, and also the YouTube chat the chat box in the YouTube channel. All right, while waiting for questions, all right, we give our audience some time, and also because of the delay, I actually have a questions for Boon Wei. Back to the first of January airport. We have 12 moons because there is 12 full moons in each month. Let's say if so happen that there's one month there's this blue moon, that means there's two full moon. How this image will be seen?
What?
Any
Sorry?
idea?
You mean
Let's say if we have the blue moon. So how will the image be seen? Imagine, can you imagine?
I'm very sure in this picture, some of the months are blue moon, you know. So which one to select? Like what I said.
Which one to
Which one
select?
to select? The first blue moon or the end of the month blue moon? A blue moon is a 12 moon in a month where in 1 month it's possible to have 2 full moon. So the second full moon of the month is called a blue moon. So if in that month there's one normal full moon and the one blue moon, so which is the one he will select?
Any idea?
Any idea?
Wow, this one I also cannot. I also think maybe he will just choose one moon because because he actually taking with different, try to take in different size one ma.
Maybe. I'm not sure.
Cannot sure. But then in this caption they said in May and November got the lunar eclipse. Is it May and November in this year also have the lunar eclipse?
This year. When?
Also
May
and November. Actually I find also it seems like the same month.
May lunar eclipse.
Yep. But the May one we cannot see.
I don't see in our astronomical calendar.
I think there's one. I
go
think there's
here.
one later in the year. I think I forgot it's October or what.
November.
There's
November we
no.
can see.
Yeah, there's the eclipse at the moonrise.
Yeah, the eclipse at the moonrise.
Yes, 8th of November.
Oh yeah.
8th of November, total night eclipse.
What is it? The is it the same month will happen the lunar eclipse one, or sometimes will be different?
Will different, depends. Usually if you have lunar eclipse, then you have solar eclipse, then you have lunar eclipse after that.
Like just now you mentioned that William Chin asked a question. I don't hear exactly something about astrophotography in Malaysia. So
No, he's making a comment instead of asking a question, I think.
Okay.
Yeah, because just now we say the comet. Because the comet is in the morning sky.
Yeah.
So we also know that astrophotographer in Malaysia has a big problem of the weather. Malaysia near tropical country, a lot of clouds, a lot of moisture in the air. So I'm now waiting for someone in the world to try this drone astrophotography. Because you have a powerful drone, not expensive. You can go to 3,000 feet high above the clouds. You cannot put your telescope with tracking, no. Just landscape photography. So below the drone, you have a camera. Digital camera can look at the horizon, take a picture of whatever object in the sky at night. Let's say, wow, you are 3,000 feet high. The camera held by the drone, you can take the Milky Way. Right? It's possible. So I think, we hope maybe one day somebody will try it. Astrophotography from a drone, it will revolutionize astronomy, above the clouds.
But there's limits on drone altitude. You can't go too high. The maximum is a few hundred meters. Because if you go beyond that altitude, you need to apply permit from this
So basically,
DCA.
What
Now
line?
no longer called DCA. I think it changed the name. I
know.
Already.
So that I'm not aware of. Thanks for letting me know. But from a technical point of view, the drone can fly high. But from a legal point of view, it may not be allowed. Unless you do it, then you'll be summoned by the court later. But it's possible, no? You go to a remote area, you fly 3,000 feet, 5,000 feet above the clouds, you get 2 astrophotographs.
Depends of what type of cloud you have lah. If those thick clouds, then maybe you need to you need to fly higher altitude. For example, the cumulonimbus cloud I present just now, that one, if you met that clouds, then sorry lah, because that clouds, it can go up to 20,000 feet, I think.
Like for example,
50,000 feet.
we have seen a
So-
lot of sunrise from Penang Hill in the morning. So imagine you are from Bellevue Hotel, you look at the east, where the level of Bellevue Hotel to the ground, it's a thick layer of chocolate cloud. You know? It's actually pollution, all the industrial and exhaust pollution. But above it, clear sky, you know, quite blue. So many parts of the world is the same thing. The valley in the city is trapping all the air, like KL. So if you go up to say 3,000 feet high, above you no clouds, you know, it's basically the pollution that's it, blocking the clear sky. So that's why you go to Penang Hill, you take a morning sky. Sometimes below you is the industrial pollution, above you is a clear sky. So with the drone, it's possible, but the problem is the legal thing lah. That's it lah.
By the way, this morning I actually taken a very nice sunrise photo.
Yes.
You can see the full sun, the egg yolk sun.
Yeah.
It's actually quite cloudy. I'm not sure it's hazy these few days.
So, Lai, any more questions?
Okay, I don't see any questions from Facebook and YouTube side. So yeah, I think maybe Dr. Chong.
Yeah. Okay, so we just wrap up. So okay, Bombay, Lai, we are 1.5 years old. No, we are very young. We're still young baby.
Still young.
See, so we hope to be able to ask more of our Malaysians to watch this program to explain. So we hope that in the months and years to come, more exciting things. But now so I would say, in this coming 6 months, we expect the first few pictures, the first light pictures from James Webb Space Telescope to appear in APOD. Sure will appear one. So get ready for the James Webb Space Telescope. And of course, I'm sure with all the new astrophotographers in the world and the new spacecraft, a lot of things will come. And just right in my mind, what's happening next week? Beijing Winter Olympics. Hopefully, maybe some of the amateur astrophotographers in China will wait during daytime. They come down the ski slope and some very nice sun effect. Take a picture of the ski slope, the skier coming down the ski slope, and the blue sky is something. Or at night, the ski village or the ski slope with the constellation in the sky. That'll be nice. It'll be big. So anything can happen in APOD 1. Anything. But for us in Malaysia, like this, Boon Wei, many of those astrophotographers know what to do. Always they carry in their hand a camera and a camera stand. No need telescope, quite heavy. With the camera and a camera stand, you can take nice picture. So put in your pocket compact camera or DSLR camera, even handphone cameras, which you know how to take astrophoto all the time. Anything can come. You just don't see it, you miss it, gone. You are at the right place at the right time. That's what it is. To always be very observant. Like what Lai presented just now in Canada, the atmospheric cumulonimbus cloud also gone. So a weather phenomena can be accepted by what they call APOD, So get ready your camera all the time.
Is it we have to hashtag APOD?
Yeah.
To be selected for the photo to be selected.
Yeah. So what I'm saying is that you can take those APOD pictures that a camera can take itself. So you must sling along your back, that camera back all the time, with your tripod, all the time. Anywhere you go, you must carry that. Just like they say that geologists, the ones who study rocks, the lecturers, everywhere they travel in Malaysia, they have a geological hammer at the boot of their car. Hey, somebody Ipoh, the road, interesting rock, they come up with the car, take the hammer and break the rock. A geological hammer, carry all the time. So for us, it's a camera. Yeah, right.
And we also encourage our Malaysian. You don't need to be professional astronomers, but then you can just take any interesting photos and submit to APOD and try your luck whether your photos will be selected and published in APOD. We're looking forward for these Malaysian APODers.
So I forgot to add on just now. So we already have ours, our own society. Michael
Yep.
Teo, his solar sunspot pictures in airport, and our earlier one is our William Chin, all right, and also this Teo Wee Chie, and our own member also Dr. Derek Lin. All right, so we hope more of them, these people, and even new Malaysian astrophotographers to take those pictures accepted by airport. Remember, once your picture is put in airport, you have achieved it. You are in the club already. You are in a very selected club. Like this.
Yeah. So I think that's all.
Okay, so now we
Yeah.
gear up for James Webb Space Telescope, the pictures, all right? So remember, James Webb is supposed to see infrared further than Hubble. So maybe in a year's time, they will take the James Webb Space Telescope, mega, ultra, super, ultra deep field. Very further. But unfortunately, James Webb cannot see the Big Bang. In future, we have to wait for that telescope to see the Big Bang. Okay. So well done, everyone. Okay, thank you, Michael. All right.
Okay, thank you.
Good
Thank
night.
you.
Right.